Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the sum s of n equals n cubed plus 3n squared plus 5n plus 3 is divisible by 3. Okay, let us begin. Now here, what we'll do, we're going to name the statement as Pn. So let Pn be the statement. So our goal will be to show that the statement P of n is true for any natural number that we pick up. But for that, first let's pick up one natural number. We're going to pick up the first natural number, which is 1. So for n equals to 1, our statement will then become P of 1 such that S of 1 that will be equals to, so we're 1 cube plus 3 times 1 squared plus 5n plus 3, 1 cube plus 3 times 1 squared plus 5 times 1 plus 3. So this is going to be equals to 12. And we know that 12 is clearly divisible by 3. Now since 12 is divisible by 3, this only tells us that the given statement P of n is true for n equals to 1. Now if it is true for n equals to 1, so we will make an assumption here. We'll suppose that let P of m is also true. So this is an assumption that we are making. So we are considering P of m to be true. If P of m is true, that means that the statement P of m, this simply means we are rewriting the statement P of m as S of m equals to m cube plus 3 times m squared added to 5 times m plus 3. So this expression is divisible by 3. Is divisible by 3. Now next what we'll do, we will try to show that the next consecutive natural number that we choose, that means m plus 1, we'll have to show that m plus 1, P of m plus 1 is also true. In other words, what we have to show here is that P of m plus 1 such that we have S of m plus 1 equals to, replace this m value with m plus 1. So we have m plus 1 whole cube added to 3 times m plus 1 whole squared added to 5 times m plus 1 added to 3. We have to show that this is divisible by 3. Fine. This is what we need to show. Now, how do we show that this is true? So here we're going to use the fact that since P of m is true, since we have already considered P of m is true. If it is true, this simply means that m cube, this implies that m cube plus 3 times m squared plus 5m added to 3. So since this is divisible by 3, we can say this is equals to 3 times some number lambda, where lambda, we have to specify what is lambda here, where lambda is some natural number. Fine. That's what it means when we say it's 3 times lambda, means it's simply divisible by 3. If it is divisible by 3, now what we can do now, what is S of m plus 1? So S of m plus 1, that's simply m plus 1 whole cube plus 3 times m plus 1 whole squared added to 5 times m plus 1 plus 3. So we have to show that this particular expression is divisible by 3. Now how do we show that it's divisible by 3? What we will do, we're going to expand it. This is going to be equals to m cube plus 3 times m squared added to 3 times m plus 1 added to, so we have 3 multiplied to m plus 1 whole square, so that's 3 times m squared plus 6m plus 3 added to 5 times m added to 5 plus 3. Now what we'll do, we're going to combine some of the terms. So first we're going to consider the term m cube. So this particular m cube that we will be considering. Then we will be considering 3m squared. So we have positive 3m squared, followed by we need 5m. So here we will be choosing this particular 5m, and then we have 3. So we are choosing these 4 terms specifically so that we can substitute it with 3 times lambda. Fine. Then we have the rest of the terms. We have 3 times m squared. So this is done. Then we have 3m plus 6m. So that corresponds to 9m added to, we have 1 plus 3, so that's 4. 4 added to 5, so that's 9. Fine. Now what we can do, we can replace this with 3 lambda, the first 4 terms. Then we have 3 times m squared plus 9m plus 9. 3 times m squared plus 9m plus 9. Now from each of the terms, we can take 3 as the common factor, such that we have 3 multiplied to lambda plus m squared plus 3m added to 3. So this is the expression for s of m plus 1. Now lambda is a natural number, m is also a natural number. So here this particular expression is nothing but some other natural number, which we can say is simply 3 times beta, where we are supposing that beta equals to lambda plus m squared plus 3m plus 3. We don't have to worry about the values of lambda and m here. As long as they're natural numbers, beta is also going to be a natural number. So we can say that beta here is a natural number. So that means we have obtained s of m plus 1 as 3 times some constant beta, which is a natural number. And this simply tells us that the entire expression that we started out with, s of m plus 1, so that expression is divisible by 3. So this means that now we can finally say that this implies that s of m plus 1, so this particular expression is divisible by 3. This is divisible by 3. If it is divisible by 3, that means this implies that p of m plus 1, so this is indeed a true statement. So we have successfully showed that p of m plus 1 is a true statement. Now finally we can say if this is a true statement, hence we can say that the statement p of n is a true statement. This is a true statement for all values of n belonging to the set of natural numbers. That means any natural number that we pick up, the statement p of n, which is given by s of n equals to n cubed plus 3n squared plus 5n plus 3, this is always going to be divisible by 3. So we have successfully proved our problem by using the principle of mathematical induction.